Our next transformation that we are covering is dilations. Our objective will be to identify and use dilations. In order to warm up, we've got a couple proportions to solve, so make sure you write these in your notes where we are saying warm up, solve the proportions, 1 and 2. We cross multiply and we set the cross products equal to each other. So that means that we multiply 9 times x. What is 9 times x? 9x. We set that equal to 4 times 45. What's 4 times 45? It is not 1800. It's 180. Then we still have to solve it. What do we do to solve? Divide by 9. What do we get for x? 20 would be the correct answer. On number 2, we again cross multiply 7 and n. What do we get? 7n equals, what is 49 times 12? 588, do we agree? Then what do we have to do? Divide by 7, what do we get? 84 sounds good to me. All right, our vocab for today is all in your guided notes. So we don't have a separate vocab sheet. A dilation is a transformation with scale factor K and center C that maps each point to an image P prime so that the original point P is between the center and K. So the image gets bigger and smaller. That's the important thing to know, bigger and smaller. We'll worry about the scale factor and the center and P prime and all that when we do examples. When an image is smaller than the original, we call it a reduction. When an image is larger than the original figure, we call it an enlargement. On our first example, all we are doing is saying if the dilation is a reduction or an enlargement. So remember the plane points, that's our original figure. The one that has the primes or the little tick marks by them, that is the new figure. So we really just have to decide, did it get bigger or did it get smaller?
Small.
On number 1, what do we think?
Small. Bigger.
Let's do thumbs up if you think it's bigger, thumbs down if you think it's smaller. Oh, I see a mixed review here. So here, we have our original figure. If you ask me, if we were to put this on top of the new figure, the original one is small, the new one is bigger. That makes it an enlargement. If the new figure is bigger, it's an enlargement. That's a great question. How do we know which one's the new one? Angel? Look at the primes. The primes makes our new figure. So if it's hard to see with those lines there, here's the old one, here's the new one. Also, we can see, especially on this one, that our new one is farther away from our center, C. That's like our reference point. It's further away, it got bigger. On part B, for example 1, let's see, thumbs up, thumbs down. Thumbs up, it's an enlargement, it got bigger. Thumbs down, it's a reduction, it got smaller. I'm seeing mostly thumbs down, which is a good thing. Our original figure is here on the outside. It's larger, meaning our new figure is smaller. So it was a reduction. Also notice that on part B, our new figure got closer to the center. The distance from the center to a point with a prime is smaller. It got closer. The scale factor of a dilation is the ratio of CP prime to CP. What this means is the distance between the center and a new point compared to the distance between the center and an old point. So this refers to distance between the center and a new point. This one's going to be the distance between center and an old point or original point. Okay, and it doesn't matter which point you use. So usually we'll refer to P and P prime, but it doesn't matter if you want to use Q, Q prime. It'll be the same thing. It is a ratio, meaning we write it as a fraction. So if you want, put a big note that these should always be written as a fraction. Don't give me a decimal on those. All right, on example 2, we are finding the scale factor of the dilation. What that means is we're finding the ratio of CP prime to CP. So on part A, what is the distance between C and P prime? 2. They labeled that nicely for us. So we'll have 2 over the distance between C and P. What's the distance between C and P? 3. Can that be reduced? No. So our scale factor, or K, is equal to 2/3. On example 2A, do we think that this looks like an enlargement or a reduction? Let's do thumbs up, thumbs down. Thumbs up, enlargement, thumbs down, reduction. We've got another mixed review here. If you said reduction, you are correct. The P prime is at an image that is smaller. So it got reduced. It was made smaller. Notice that your scale factor is a number that is smaller than 1. Anytime you have a reduction, your scale factor will be a fraction smaller than 1. It's a nice thing to know. All right, on part B, what is the distance between C and P prime? C and P prime.
6.
6. The distance between C and P. 3. Can that one be reduced?
Yeah.
What does it become?
2/1.
2/1. If you want to just write it as 2, that's fine.
Can we leave it 2/1?
Yep, leaving it 2/1 is also okay. On part B, thumbs up, thumbs down. Is this an enlargement or a reduction? I should see all of those thumbs facing up. This is an enlargement. The image with P prime is bigger than the original. Is our scale factor bigger or smaller than 1? Bigger. If your scale factor is bigger than 1, it's going to be an enlargement. Make it bigger. If you want to write yourself a note, you can. So if your scale factor is greater than 1, it's going to be an enlargement. Oh, that's hard to see all the way up there. If your scale factor is less than 1, it's going to be a reduction. Knowing that and keeping that in mind can be a nice way to check yourself on problems sometimes. Tell whether the dilation is a reduction or enlargement, then find the scale factor. All right, on example 3, part 1. Let's do thumbs up, thumbs down. Do we think this is an enlargement or a reduction? I'm not seeing enough thumbs.
Wait, what
We are on example 3, part 1.
It's enlargement.
So show me with your thumb. Thumb up, enlargement, thumb down, reduction. I should see thumbs going up. This is an enlargement. P prime is at a bigger image than P. We also need to find the scale factor, K. So to find the scale factor, we compare the distance from our center, point C, to a new point, P prime. What's that? 10. We compare that to the distance between that and the distance from the center to an original point. In this case, that's 5. This will reduce to 2 over 1 or 2. So that makes sense. We said it was an enlargement. Our scale factor is bigger than 1. Life is good. We can move on unless we have any questions. Okay. On the next one, I think it's a little funny how they have that drawn. So in case you can't see it, that's our new figure. And this one out here is our original figure. Let's do thumbs up, thumbs down again. Is this an enlargement? Thumbs up for enlargement or thumbs down for reduction? We should be saying thumbs down. This one got smaller. It is a reduction. We still need to find our scale factor K. K equals, what's the distance between our center and a new point? I think I hear someone saying 8. Center and new point, that distance is 8. Compared to a distance between the center and an original point. Center, original point has a length of 24. Can this scale factor be reduced? Yes, what does it become? 1/3. And again, our scale factor is smaller than 1. It was a reduction, so that makes sense. Are we ready to continue? All right. We got a lot going on in this diagram. We are told that P prime, Q prime, R prime is the image of triangle PQR after a reduction. So they told us in the problem that it's a reduction. We are asked to find the value of x. So x up here is the length of QR. So we are going to have to use our scale factor. So the first thing they ask us to do is find the scale factor. CP prime over CP. What's the distance between C and P prime? 8 over 14. Will that reduce? Yes, they're both even. They can be divided by 2. It reduces to 4 over 7. Okay. So, the substitute, that's kind of a weird... Oh, I get what they were wanting us to do. That's not what they want us to do on that step. That's okay. What they wanted us to do was write a proportion that compared CP prime to CP, and they wanted us to do the same thing for like Q prime R prime to QR. So we'll just change this step a little bit here. If you write it off to the side or fill it in here, it's fine, but making this comparison is going to be the same as comparing Q prime R prime to QR. We're allowed to do that. So what they wanted there was CP prime compared to CP is the same as Q prime R prime compared to QR. So we already figured out C prime CP is 4/7. What's the distance of Q prime R prime? 6 over, what's the distance of QR? We labeled it as X. So now we're kind of on the right track here of what they were wanting us to do. This is why our warm-up was cross products, solving proportions. We have to cross multiply. When I cross multiply, what do I get? 4x equals 42. Well, this step we kind of eliminated because we multiplied and did our cross products at the same time. And then we divide each side by 4. What do we get for x? I think it should be 13. So we did it a little differently than the steps they'd written out for us, but that's okay. We did it the same way, we got the same answer. All right, on these last two, we have to find the value of the variable. So let's first work on setting up our proportions. So we know we need the scale factor. We have the scale factor by comparing CP prime. So what's CP prime? C to P prime. Oh, well, sorry, they didn't label the P source. So a point C to a point that's at the same figure as P prime. Let's do it that way. What's that distance? 20 over C to our original figure, 8. Can we reduce that? What does it become? We can do it more than that. 5 and 2, we said. All right, so then we have to set up a proportion. So notice that when we do these, we do new over old every time. The scale factor and, bless you, this other one. We do new over old. So, what's missing from our new figure? What side are we looking for from our new figure? M. And what does it match up with from our old figure? 2. So this should be a really easy proportion to solve. What's M going to equal? Well, 2M will equal 10, and M will end up equaling 5. All right, on this last one, remember we do new over old, new over old. Yes, we will have homework. So, let's start with our scale factor that we know. What is a new side that we know? Give me either new side. I'll get it in a minute. What's a new side that we know? Look at a side on the one that is labeled with a P prime. Give me one of those sides. N. On the old figure, what side would match up with that? 4. And we can set that equal to, give me another new side. 3, and it would match up with 6. When we cross multiply, we get 6n equals 12, and then to get n by itself, we divide and n equals 2.